Okay, welcome back, students. So we're going on to question 12 from the 2024 paper. And the first thing we need to do is continue this pattern, draw pattern 4. So the way I'm seeing this is that in its essence, it's going to be a square of 6 boxes. Okay? So I'm going to draw across 6 boxes. 1, 2, 3, 4, 5, 6, and down 6 boxes. I'm not too worried about construction lines, so I'll be generous and do some extra if I need to, just to get the job done reasonably quickly. Okay, now I can see top left is shaded, top right is shaded, bottom right is shaded, and then the entire diagonal is shaded. So I would favor the idea of hatching rather than shading everything in, but overall that's our shape for our fourth pattern. Okay, now we're going to say filling in the number of shaded squares. We have 4, we have 5, we have 6, 7, 8. Now, in terms of what is it going to be in pattern N, it's a linear sequence with a difference of 1, common difference of 1, and term N will be 3. Okay? You could do it much slower, but you could do it with simultaneous equations, which will bring us out to sequences, page 22. We'll have us write down the formula here. Term N equals A plus N minus 1D, which will give us term 1 equals A, because 1 take away 1 is 0, but we know term 1 equals A is equal to 4, so we know that A is 4, and term 2 equals A plus, now 2 take away 1 is 1, so A plus D equals 5, and if we sub in the 4 here, we get D equals 1. Well, we knew that already, did we? We knew the first term, and we knew D equals 1. Yeah, so it's we model it, sorry, as term N equals A plus BN, and term 1 equals A plus B, and term 2 equals A plus 2B. And we know term 1 is 4 and this is 5. Now if we subtract up the way, we get B equals 1, A equals 3. You can see it's quite a lot slower than just doing the term 0 method. Okay. Now the total number of squares is 3 3s, then 4 4s, then 5 5s, then 6 6s, and then 7 7s. And they tell us that that's N plus 2. So far so good. We've got a score of 5 over 5 so far. Okay, then they go on and tell us in pattern K, which is another index, it could be N, it could be K, the difference between the total number of squares and the number of shaded squares is 271. Show that this means the following, 271. Okay, so we're going to say This is the total number of squares replacing n with k. So we're going to find out that k plus 2 to be squared from here minus k plus 3 should be equal to this expression. Let's see. Well, we're going to square this out, which will be the square of this plus double the cross product plus the square on the second minus this entire expression, so you just negate each term. That's k squared. 4k minus k is 3k, and 4 take away 3 is 1. And so we've calculated that it is indeed a difference, and then they tell us that it's equal to 271, so we set that to 271. We're just going to take a quick look at the marking scheme. So again, they do that direct, they square that out directly the same way that we did here, and then they negate. We set it to 271 and they get to here, and there's no extra maths needed. Now we're going to solve this equation. So to solve the equation, the strategy we have, no matter whether you're factorizing or using the minus b formula or any other method, is to bring all terms to one side. So we're going to transpose back the 271, the change sign of 271, giving us k squared plus 3k minus 270 equals 0. Now, while this does factorize, it's probably best to use the minus b formula, because the factors of 270 is a highly composite number. So I'm going to do it both ways. So we'll first of all look at those factors, and we'll see there's 270 is 2 by 3 cubed by 5, and we would need to find two factors of this that have a difference of 3. Okay, so I mean, I can see 3 5s is 15 and 2 9s is 18, and they're the numbers I need. I go into a factor, the factor frame, or the big X some teachers call it, and I would know I need an 18 and a 15 and an X and an X, and that the 18 wants to be positive because it is plus. Okay, but if you find this difficult, and I do think it is difficult, because 270, as I said, is quite a composite number, so there's quite a lot of work here. Now, by the way, I used X there, but I should have been using K. And I must remember k is inherently positive, because what it is, it's the domain of the terms of the sequence, and the domain is the natural numbers. So there's no way we can allow a negative number. So just changing these to a k, because that's what they were supposed to be. I can say a candidate solution is negative 18, and another candidate solution is 15, but I must reject this one because it's negative, and keep only the 15, and that's what this is about here. Okay, now I will say, using a equals 1, b equals 3, and c equals minus 270, in minus b plus or minus the square root of b squared minus 4ac all over 2a, where you only use the positive version to get 15, and you neglect or you dismiss or reject the negative solution because it doesn't make sense in this context. Okay, so I would be favoring this, students. I'd say to you, do it this way, if you don't just love factoring, and very few students do. So that's it, guys. As always, see you in the next one.